it actually worked out. But there were a lot of things that we learned along the way. And to sum up that journey, I want to present to you all the things that I'm going to talk about in this talk, such that you don't have to make the same mistakes. Right? So build with a pattern of the universe. What does that mean? Well, it's a journey, once again. So the roadmap, plan and attack, is to cover architecture, what it means within the context of this talk. We're going to cover quality, because that's super subjective and presumptuous for me to define quality, so I'm going to let other people do it. We're going to go through the mindset, expound upon that a little bit more, because when you're developing software, the right mindset is actually easier to do the right thing than it is to do the quick and dirty thing. And a lot of people make that judgment call up front, and you don't have to do that. After that, I'm going to get out of the nebulous, crazy stuff and come down to actual principles and examples that you can hopefully apply to your engineering practice. And I'm going to close it off with some trippy images. All right. So let's get started. Architecture. The complex or carefully designed structure of something. Started with a definition. Yeah, it's super original. So many of the things that we do as engineers is like built around building the right thing. You know, like we do all this planning, we do offsites, whiteboarding, figure out the business process, because we want to figure out how to build the right thing every single time. Why do y'all think that is? Why is it so important to build the right thing?
Scale. Because it sucks to build the wrong thing?
Scale? Why does it suck to build the wrong thing?
Gotta do it again.
Gotta do it again. And how long did it take to build the wrong thing? Estimates? How long did it take to build the wrong thing?
Just long the same amount of time as it would do the right thing.
True, but at the same, yeah, that's the main thing. So we wanted to reduce the cost is the issue here. On my end, as an engineer, with slightly less input over the product direction, though we do have a lot of input, sometimes you're going to build the wrong thing. And so as an engineer, my focus has been reducing the time to build anything so that we can take more shots faster and better, in this case. And that's something that good architecture allows us to do. So it's way better to build the right thing first. But if we build the wrong thing, we want to make that cheap. So we can build tons of wrong or right things. That's what we do as engineers. But we'll never be able to do that if we don't build an architecture with which we can build upon. And so that's what this can be centered around. Because a high volume of high quality shots is how we win. Just want to take the most. A lot of the NBA games, it really comes down to taking the most shots. I'm not an NBA expert either, so like that could be wrong. Kobe definitely has the most shots. On the flip side, bad architecture is a burden for the entire org to bear. You pay off that debt for years. Dramatic image of an albatross. So bad architecture leads to a lot of these things right here. And the biggest one is, for me, is new engineers propagate the old mistakes. That's the most insidious issue with bad architecture. Imagine it like a fractal or a seed that you plant. That's the first architecture. Whether you like it or not, that's the one that's going to keep going if your company exists. And you need more tests. So if your code looks like this, you're going to have to write a lot of tests. That's like the main thing. There's duct tape on the door. You got to test the duct tape to make sure the new roof shingles don't break the duct tape. That's bad architecture. With good architecture, you don't have to test every single thing because you're not as paranoid about the whole situation. So it's important to get this right. It's important to really think about quality architecture, which brings me to my next point. What is quality? Oh, I forgot to swap this image. So I Googled principles of software engineering and came up with this stuff, which we're all really familiar with, especially junior devs. We all did it. We abstracted everything. And that's my problem with principles of software engineering is without a North Star to build towards, these are just tools in your tool chest. And it could either make you or ruin you. all run into a lot of painful abstractions before, I'm sure. Where it's just like, why does it work this way? Now I have to pass all these variables into it to make it do something that seems like it should be unrelated. So what does quality mean to you? Now we do an audience activity where you neighbor and describe what quality software looks like, just for you. Give it a minute, and then we'll like call stuff out. Yeah. Cool. 1 minute. What do you think quality is?
Well tested. Look really good. Yeah, it's true. Easy to read. Yeah. Good naming goes a long way. Yes. Rigid.
Okay.
Flexible.
The clarity comes with
Thought we were doing Anthony.
because if you understand the window time, you can manipulate, so you can scale, you can extend it. It takes you through this. I think that's
10 seconds to start summarizing your points. Last I'll share.
Learn 4 languages, you don't understand the syntax.
All right. So I heard some really good ones. I heard an Einstein quote actually from that section. But can y'all share to me with me what quality means to you? Anyone? Shoot.
Readable.
Readable, human readable. That's a good clarification. Who else?
Self-documenting.
Self-documenting, all right. What's up, Ubi?
The amount of time that takes you to understand something
Is low.
Yeah, has to be low.
Got it. Anything else?
Reliable.
Reliable, I like that. Oh. Anything else?
Scalable.
What was that?
Scalable.
Scalable, okay. In what terms?
It's easy to add things and delete things.
Nice. All right. Anything else? Not captured here?
Orthogonal.
It works. For the last thing on the list. It probably does its job. Orthogonal, can you expound upon that?
Yeah, like it's modular in that like the different features can work with other features, not coupled to each other.
Cool. I wish I could wrap this text, but we're gonna keep going. Sweet. I like this list.
Commas.
Commas, no. All right. So now I'm going to tie all of these concepts of quality to Robert Pirsig's version of quality, which is something that's kind of synonymous with harmony. And we're going back up there right now. So in Zen and the Art of Motorcycle Maintenance, who's read this book before? All right. About a fifth of the room. It's pretty good. So for those who haven't read it yet, oh man, my notes are here. All right. For those who haven't read it, it's a book that follows a former professor and his son, as well as their friends, on a journey through the middle of America on motorcycles. And throughout these long interstates, they didn't have walkie-talkies back then, so he's just thinking about his life and reflecting upon all of the values and lessons that he's learned the whole time. And I think different people derive different things from this book, but because I'm a nerd, I directly applied it to engineering. and it's the particular section where he compared and contrasted him and his friend and their attitude towards motorcycle maintenance. The professor, he really liked to get into the weeds of how the motorcycle worked. He liked to figure out how the carburetor worked, what things to wrench on, and he derived a lot of joy from it. His friend thought it looked really cool, and he wanted to take it to the shop whenever it broke. And for Robert, this was a trip for him because it mirrored another dichotomy in his life, and that was in a previous life he was a professor and he had to teach a rhetoric class. And he had the hardest time grading papers because they were graded on quality. But to him, you couldn't really quantify quality, right? We have rules of grammar, we have rules of a proper essay structure. But he found that a lot of the students who did all of the logistical things right, the quantitative things right, they're still kind of shitty papers. And then on the other side, there's the people who are like more like artists or unstructured with their writing. So by all the quantitative measures, they were bad papers, but they were great. And so he determined that there had to be something deeper. And where that ties back together is that he concluded that quality is the intersection between the perception, the aesthetic perception of the product or the object, as well as its underlying implementation. Can you guess which one was Robert's friend's motorcycle? Robert's friend is an artist, by the way. We'll do it by brands. Did Robert's friend drive the BMW or the Yamaha? BMW. It's the BMW, of course. He's a Beamer driver, man. So this is a really long quote. That was the one that jumped out to me. Let's popcorn read it. Who wants to go first? Ian.
The result is rather typical of modern technology. The overall dullness and appearance so depressing that it must be overlaid with a veneer of style to make it acceptable. And that, to anyone who is sensitive to romantic quality, just makes it all the worse.
Next popcorn. Ian, pick anyone.
Jeremy.
Nice.
Plastic stylized toys for stylized children who at Christmas and birthdays are in style with their stylish parents. You have to be awfully stylish yourself not to get sick of it once in a while.
Right. Keep popcorn in it.
Let's go drum ropes.
Thank you, Jeremy. It's the style that gets you technological ugliness served over with romantic phoniness in an effort to produce beauty and profit by people who, though stylish, don't know where to start because no one has ever told them that there's such a thing as quality in this world, and it's real, not style. Jeremy. Okay. Yvette?
Yvette, it's your turn to read. She was lying down for anyone who didn't see that. We're almost there. It's 2 more sentences, y'all.
Quality isn't something you lay on top of subjects and objects like tinsel on a Christmas tree. Popcorn Marcus.
Whoa. That worked out really well. Real quality must be the source of the subjects and objects, the cone from which the tree must start. All right. So Steve Jobs was notorious for caring about every single part of the Mac, down to the screws, which the engineers said you can't see. He didn't care. Nature is inevitably harmonious. There's no extra embellishments to things produced by nature. You don't have 2 eyeballs for fun. It's all functional. It's all created by organic evolution. And so the mindset, what's the mindset that we need for building products that scale and scale with the organization? And we're not talking requests per second this time, because every time I hear scale, it's always about how can our server handle this thing. But no one really talks about how do we make this code base actually scale to the size of our org. So really quick, any examples of things that scale well? And you just call them out. What was that? Vector graphics. Ah, nice. Anything else?
MongoDB.
MongoDB? That was a joke. April Fools. Anything else?
Anthills.
Anthills. Anthills do scale well.
Lego blocks.
Well, Lego blocks scale very well as well.
Rabbits.
All of these things have nature in common. It's nature. It's kind of a joke. So, this is one of those things where you Google image search universe and eyeball, and it comes up with like this thing. And what I'm trying to get across here is the universe repeats the same pattern fractally at every level of scale. And if we want to create code that scales well, we do well for ourselves if we learn from nature, because it's been going and doing this longer than we have. So it repeats itself from the atomic level to the universal level. And that's something that we can actually apply when building software. So how? You gotta build like nature. Drone photography. You can say any corny thing on top of it with the serif font, and if it's drone photography, it'll probably work. So what is that? That's serif. Is it not? Yeah, it's serif. Come on, y'all. What does that entail? All right, so now we get to the part where it's code. So declarative code, we've all heard it. React is so declarative. Declarative. What does that mean? I've explained this like hell of times. So it actually just means show, don't tell. We should architect our software kind of like how Google Maps works for the zoom levels. It works. This works really well for the front end. When you open up the app.jsx, I don't want to see how you're handling file attachments. I just want to see where the header, body, and footer are. Maybe where the state manager gets started. So you look at Google Maps, you can see the countries and the continents. I don't see the 101 North. So once we jump into that top level of the code, then every other engineer can decide where they want to zoom in. Yes. So maybe they want to zoom on the United States. Okay, so maybe now we're in like the form, the create page. And maybe there's something wrong with the drawer that holds the advanced options. California. Enhance. We can keep zooming in, and this allows us to keep this much complexity in our mind, as well as this much. Because at every level, we get to reset it. It's a fixed amount of complexity at the local level, even though the system is incredibly complex. And that's how we build code that scales. So it also applies to the federal government, but I'm not going to get into that at all. So what does this look like as far as code goes? This is one of the first things that we made with our core components. That's our component library made by Ferris, Randy, and the fantastic Blue team. It's a file attacher. As you can tell, it's more complicated than an on-change values, sure. But that's all we need to know about. And if I'm just going to use it, this is great. If I need to add a feature, if there's a bug, we got to zoom in. Zoom. This is the render method. Can somebody call out the specific components of this thing? Anyone? Like the discrete components? Anything? Container, right. So we got it. Oh, there it is. I was like, man, there's no container. All right, so we have the container. That's kind of self-explanatory. It takes no props. What else we got?
Drop zone.
Drop zone. Drop zone has its own interface. Kind of makes sense for a drop zone. Anything else?
Tokens.
Tokens, right. See this one? The how is kind of leaking into there. That's an if statement. We don't want to do that. And we also have the state. So if I added a file and two files kept showing up in the tokens, what's up, Ian?
Just a question.
Sure.
The dots in the component names, is that like a syntax thing, or?
Yeah, that's more like an organizational thing. So there's a file attacher object, and we're assigning the keys as subcomponents. It's not advisable because you can't tree shake it, but this was written before that.
Okay.
Yeah, so if I had an issue with, I drag a file onto this thing and it attached to the same file, where do you think I should deal with that? Which component?
Drop zone.
Drop zone? That's one call. Could be drop zone. It could be happening on the attach, right? It also could be happening in the state. They might be having two things. I think drop zone was the right answer, actually. Who said that? Nice. I just made this example up right now. So. You're right. You check the drop zone, but the next zoom level is state. And this is all of the functionality encapsulated within that drop zone.state, the file attacher.state. Now I want to see this when I'm just trying to figure out how the damn thing works. You want to figure out how it works, let's just figure out what the actions are and like what the state is. And then if we have to zoom in, we can zoom in. Because that's a lot for any developer to see up front, along with the rest of the stuff. So one rule of thumb that we've been living and growing with is at each level only describes itself and its children. It's like a parent-child relationship. The parent level shouldn't know about the great-great-great-grandchildren because now that code is super coupled to the component hierarchy. Just know about yourself and the level below. That's it. If you do that, we can build up into infinity. And at every level, it's just parent-child, parent-child, parent-child. You get issues, that's why we try to avoid global objects, because that creates coupling to some nebulous top-level thing. We want to reduce coupling at every level. Any questions about declarative code so far? No? Good. Fantastic. All right. So we want to build with composability first. It's super easy to just jump in like for 22 and down to do all-nighters or hackathons and just like hack it together. But it helps with communication. It helps with planning. I hope y'all can see this. To take the mock, break it down, and build the blocks, and then build it upwards. The thing about good architecture is it's very deliberate. And a lot of people, myself, I'm speaking for myself, I used to just want to jump in and just start slinging code. You take a moment to just think about the structure of the code, the structure of the system at every zoom level. You can come up with something like this, which is the code for a dashboard that John Rose did. You have grid, row, column, just a general card, a bidding card, project card, walkthrough card. The walkthrough's broken, I just go to walkthrough. Makes complete sense. None of this stuff is tricky, but when we're in a hurry, when there's deadlines, when you just want to get it done, sometimes you cut corners, and then you produce a pattern that if you threw 5 interns onto it, it'd be unintelligible within 3 months. If I threw 5 interns onto this thing, it'd be all right probably, in 3 months anyway. All right, next. All right, so one nature reference. Have concise interfaces. They have to mask the complexity within. Flowers, I'm not a professional on flowers. But from what I've heard, the bees really love the colors, and there's nectar inside. That's the interface. Nothing extra. Don't add extra stuff to your interfaces. Makes them hard to use. Here's another interface. Room contains a light bulb and a bloom, which is another type of light bulb. There's a ton of complexity behind communicating with the bridge. At this level, we shouldn't have to care. It should just be light bulb. And then somebody could build this in the Procore. You could bring it somewhere else. You could build on top of it. You can compose it together. But we can only do this if we scope the complexity down. That's why it's so important. And some people might be like, oh, it's just passing the entire object instead of the keys that you need. This creates coupling inherently. Watch out for it, because all these little things add up, and then it's an unmaintainable mess. Just keep it pared down and right from the beginning. A lot easier and more fun. So every level should be able to stand on its own. If you break up components and they take really specific, confusing props and can't stand on their own, it's not actually broken up. You're actually adding complexity to the system, because this component's actually not even useful unless I have 5 other ones in a global object. So in this case, we have the general information tab, which is part of a form. When we built it, we were actually going to ship it on its own. So this thing can be mounted on a Rails view as well as on a React view. And that's what building blocks that can stand on their own allows us to do. You can hedge against product changes and product bets by rearranging the components because they can all stand on their own. And it makes it more fun. You don't have to fight your code. You just rearrange it and deliver more value to the customer. Any questions so far? Nope. All right, moving forward. All right, so I can zoom into any of these with more in-depth code examples too, if y'all are interested.
I'd like to know what you meant by that can go in a React view or a Rails view.
Yeah, so we build every component in a way that it can stand on its own. So it doesn't need a Redux provider or anything. It just takes an interface of basically handlers, the logic that you inject, like on change. In this case, it's on submit. And we try to build it around the most concise interface that it can. With that, you can inject the logic for if you need to mount it inside of a React component, because then you give it a different on submit. Maybe it interfaces with Redux. Doesn't matter. Or you can make another entry point for a Rails backend and then write different logic. Basically, you want to pare it down to the most minimal interface so that it's pluggable in a number of different situations.
I mean, you still bring in the React library.
Yeah, so the React library is still built in, but it's not part of the SPA. Is what I'm getting at.
Yeah, okay.
Yeah. Yeah, any other questions?
Does that mean that all of those methods or functions or the props essentially get put in?
Yeah.
So just all of those internally are just called, there's basically a callback, essentially all of them?
Most of them, yes. So point of contact, yeah, these are all, this is data, these are some links, this is a callback right here. This thing is responsible for fetching some of its own data, and so we pass an object with links. But as long as you adhere to this interface, you can use it wherever you want. And that's why it's important to have very minimal interfaces. The more simple the interface, the more usable it is in different contexts. Any other questions? Okay, we're gonna keep going. So thinking recursively, this is where it comes back full circle to the talk we had about quality and harmony. It works really well for the front end. The front end is basically this like giant tree, or almost like a fractal structure, right? You got page has sections, or views. Views have components and subcomponents all the way down, or all the way up. Like you could compose this app into another app, presumably, and that infinitely upwards and downwards, basically. So the lowest cognitive load for the rest of your engineers is to structure components, the code itself, like how the aesthetic version looks like. So this is what you perceive. This is the underlying implementation. There's a route for general information. The sibling routes would be this, files and tenders. And it's recursive. Taking it one level further, we do the same thing with our folder structure. So yeah, recursive on the front end, recursive in the code, recursive in the folder structure. So bidding has the create page, that has the view of general information. And we repeat the pattern of components, views, utils, components, views, something similar at every level, all the way down. And because every level can stand on its own, we can take this entire view and make it part of a different app, just feed it the right interface, the right props, and it'll work. Makes it fun because if we mess something up, or we decide, oh, bid package create doesn't make any sense inside of bidding, we need to move it to change events, we just move that over. And yeah, everything's really loosely coupled at this level. So this is not a new concept. Brad Frost outlines it the best with atomic design. It's been known around the company as like fractal state management, but it's more than just fractal Redux or fractal anything else. It's fractal everything because it scales the best. The first way that we applied this mentality was to our state management, but it's actually a lot more intuitive to apply it to the way you structure your UI. And so what has that done for us at Procore? So to build like nature at Procore, we had to do a few things. Every squad used to go through a single repository with a one package JSON, and so we couldn't really evolve independently, and we just kept breaking each other's stuff. So Kyle Spinola created Hydra, which is a jet for building and deploying single-page apps from within Rails. So every single-page app has its own dependencies. So like nature, they can grow independently. On the UI side, after building, mounting, deployments covered, we built core. Back when we tried to reuse components at first, we'd start with something like the filterable table, which had a table and filters, and you had to plug in a million URLs, and then hopefully it like reloaded the stuff right. But it worked for like 2 use cases out of 25, because we didn't learn how to crawl before we ran. So we started literally with button. Started with button and input. People are like, man, you made a button component? And like box. Box took so much engineering effort. Like, you made a box component, but now our padding is never wrong. So once you start off with those small pieces, you can quickly amass enough components to build things at scale. And we compose those together for use for other people in core labs. That's the primordial soup where the components rise. People mix things together and like try it out, and hopefully it works. That's breeding ground for that. Our state management is also fractal. We used to use React and Redux Loop. We switched to MobX because it has a cleaner API and does type checking. That's a whole different talk course in itself. And our file organization is recursive. So I can mostly speak from my team, but for us, it's allowed us these benefits. We don't really write that many styles anymore because of core. Thank you, core. I have 2 other front-end engineers on my team, and with our recursive folder structure, we're able to mostly avoid merge conflicts and build almost completely in parallel. And basically, John made the files tab. Luke made the search for bidders tab, and I was able to bring them into my form wizard pretty easily. It took a day to like compose their discrete parts together in one component. And this really just enables you to build upon the things that you've learned in the past, which is what we want to do essentially. Instead of just, you're a code monkey when you have to keep throwing the same code and solve the same problem multiple times. And we're better than that. So recap, good architecture is of the utmost importance. Qualities, that harmony between the implementation and the end product that's in the user's hands, because they can feel it when the underlying architecture is not right. Just use Windows 10. It has really great animations. I used it for 3 months. It is just so bad. Like random glitches. And that betrays like a lack of architectural thinking. And the declarative, composable, fractal mindset to software engineering produces good architecture. Just think with the pattern of the universe. Build like nature. And it takes the same amount of code or less effort over time for sure, if you can just keep building upon the things that you've already done. It's like Legos. But you have to want to do it. It takes the same amount of effort or less. So build like nature, build with the pattern of the universe, and that's the end.